Time travel. The very phrase sparks the imagination. It hints at a world where we could witness historical events firsthand, right wrongs, or even glimpse the future. For centuries, this idea has captivated writers, filmmakers, and dreamers alike. But what if I told you that time travel isn't just a fantasy? What if it's woven into the very fabric of our universe, governed by laws of physics we are only beginning to understand? This is where Albert Einstein and his revolutionary theory of relativity come in. Einstein's work, particularly his theories of special and general relativity, laid the groundwork for our modern understanding of time. He demonstrated that time is not absolute as we often perceive it, but rather a relative concept intertwined with space itself. This revelation opened up extraordinary possibilities, including the potential for time travel. While the notion of time travel may seem like something straight out of science fiction, it's important to remember that science fiction often draws inspiration from real scientific principles. The quest to understand time travel, therefore, is not merely an exercise in imagination. It's a pursuit of knowledge that could fundamentally alter our understanding of the universe and our place within it. Imagine a boundless, flexible sheet. This sheet represents space-time, the four-dimensional fabric of the universe that encompasses both space and time. Now picture placing objects of varying masses onto this sheet. You'll notice that the heavier the object, the more it distorts the sheet, creating a dip or a well. This is a simplified analogy for how gravity works according to Einstein's theory of general relativity. Massive objects like stars and planets warp the fabric of space-time around them. This warping is what we experience as gravity. What's remarkable is that this warping doesn't just affect space, it affects time as well. This leads to a phenomenon known as gravitational time dilation. In essence, time flows slower in stronger gravitational fields. This means that time passes slightly slower at sea level on Earth than it does on a mountaintop, where the gravitational pull is slightly weaker. While the time difference between a mountaintop and sea level is incredibly small, it highlights a crucial point. Time is not uniform throughout the universe. This concept, known as time dilation, is a direct consequence of Einstein's theories of relativity, and it has been experimentally verified in a number of ways. One of the most compelling examples involves astronauts aboard the International Space Station, ISS. The ISS orbits Earth at a high speed, experiencing a weaker gravitational pull than we do on the surface. Due to both its speed and its distance from Earth, time passes slightly faster for astronauts on the ISS compared to those of us on Earth. Astronaut Scott Kelly, who spent nearly a year aboard the ISS, aged slightly less than his twin brother Mark, who remained on Earth during that time. This difference in aging, while minuscule, provides tangible evidence of time dilation and its real-world effects. Section 4. Peering through the looking glass. The examples of astronauts and GPS satellites demonstrate that forward time travel, albeit on a small scale, is a very real phenomenon. But what about traveling backward in time? Could we ever hope to journey into the past? Here we enter the realm of theoretical physics, where possibilities are vast and our understanding is still developing. One of the most intriguing concepts in theoretical physics is the wormhole. Imagine a shortcut through space-time connecting two distant points in the universe. Theoretically, if we could create or manipulate a wormhole, we might be able to use it to travel not only through space, but also through time. Another theoretical possibility involves cosmic strings. These are hypothetical, one-dimensional defects in space-time that are thought to have formed in the early universe. Some physicists believe that cosmic strings, if they exist, could generate immense gravitational forces capable of distorting space-time to such an extent that they create closed time-like curves, essentially loops in time that could allow for backward time travel. Section 5. Paradoxes and possibilities. The prospect of backward time travel, while tantalizing, is not without its challenges. Perhaps the most significant of these are the paradoxes inherent in time travel. The most famous of these is the grandfather paradox, where a time traveler journeys to the past and inadvertently prevents their own birth. These paradoxes highlight the complexities of time travel and the potential ramifications of altering the past. While they may seem like mere thought experiments, they raise profound questions about the nature of causality, free will, and the very fabric of reality. Despite these challenges, the pursuit of understanding time travel remains a captivating endeavor. As we continue to explore the universe and unravel the mysteries of physics, we may one day unlock the secrets of time itself. Until then, the possibility of journeying through time will continue to ignite our imaginations and fuel our thirst for knowledge.